Hey, Mr. Garb here, with a little introduction to section 3.7, which is inverse functions. So I thought I'd do that via Desmos first, and then maybe go into my open math questions. So what are inverse functions? Well, they basically undo one another. Okay, so it's a function that undoes one another. So what does that mean? That means that x's and y's are going to switch. So we're going to graph these coordinates on the next slide. So we have 0, 6, negative 1, 3, negative 2, 0, and then 6, 0, 3, negative 1, 0, negative 2, and then we're going to have 1, 5, negative 2, 1, 4, negative 2, we're going to have 5, 1, 1, negative 2, and negative 2, 4. I'm going to put those on the graph and see what happens. Let's see what we figure out. So in order to graph that, you're going to hit the little plus button and then go for the table. And I recommend you go through this process so you can learn it better. So 0, 6, get more familiar with the skill. Negative 1, 3, so negative 1, 3. And we're going to go to negative 2, 0. And 6, 0. 3, negative 1, 0, negative 2, 1, 5, negative 2, 1, 4, negative 2, 5, 1, 1, negative 2, and negative 2, 4. All right, so we have these. And let's see what happens. Those are the points that we had there. Okay, let's see what happens. The next slide. So you might notice that the relationship of these coordinates. You might see that you have x's and y's are switched. You have x and y switched, x and y switched. You might notice that. So if we graph the line y equals x right there, you're going to notice that this point right here is the exact reflection of this line. So like 0, negative 2 is the same is matched up with negative 2, 0. See, if you fold it over that line, they'd be exactly matched up. This point goes to this point goes to this point, and so forth and so on. So when you're given points as coordinates, they reflect over the line y equals x. That's the important thing to know. Okay, and the x, y values are interchanged. And that's what this says right here. It undoes it. Okay, there's a little comic for you. So basically, you see here you have plus 2 here and minus 2 here, times 5 here, and divided by here. So basically, if you do inverse operations or opposite operations, you get back to the original. That's what that's saying there. Enjoy that comic. So this is just a visual for what a function does. So you put something in, like the apples, and what do you get out? You get like lemons. And you put those lemons back in, you get back to apples. So a function, the inverse is written with a negative 1 here. So this is not negative. So this is a function f of x, and its inverse is written as f negative 1 of x. That's an inverse function, and it undoes the original function. Okay, and you probably noticed that from looking here at these values. You probably notice it undoes those values. All right, see if I can bring that down a little bit for you. Almost. You see how you have, you can't see that. Well, you can almost see it. So basically you see how these x and y values are interchanged. It's a little hard to see with the window. If I can do it right there. There you go. So now you can see your x's and your y's are interchanged. Okay, let me get that part. So I should tell you also, yeah. So another way to say that is, not only do you have x and y switching here, but also you have domain switches with range. So the range goes the range of the original function becomes the domain of the inverse, and the domain of the inverse becomes the range of the original, and vice versa. Okay, so domain and range switch, x and y values switch, interchange. All right, so f with the -1 denotes the inverse of a function. Okay, it does not mean -1 power. That's what that means right there. It does not mean -1 power. All right, so how do we find them? So if we're given an ordered pair, we can reflect them over the line y equals x like we did before, or like you saw on the graph. So if you're given a point like this, put a point over here, you know it's going to be reflected over the line y equals x, so it might be something over there like that. Okay. If you have a point here, it might be a point over here. So if you're given a point, you could find it maybe by looking at the graph first. And if you have an equation, you're going to interchange x and y and solve for y. I'm probably going to do that in a moment, okay? Switch x and y and solve for y. That's the key process. Maybe we'll have an equation coming up that we could work on. All right, so we have to find the inverse function here. Well, here, if we had to find the inverse function, we could simply interchange our x and y. So that's one function, the set of points right there. So we're going to switch those x's and y's. Okay, 5, 3. -1, -7. 3, 6. 4, 7. And that's the inverse function right there. And you can see it's reflected over the line y equals x right there. So put that line y equals x in there if I can. You won't, I don't know if you'll be able to see it, but let's see. Oh, my bad. Y equals x, not 7. All right, see how those dots are reflected over the line y equals x. It's a good little visual image for you. So that's how you find the inverse if you're given coordinates of a point. Now, same thing here. I guess they just find the inverse of the function using the table feature. So same idea here. So 6, -3, 4, 0. You'll get the nice function split over there. 2, 3. 0, 6. -2, 9. All right, so you could see there, if I draw the line y equals x, you'll be able to see again that same relationship, and now instead of just points, now we have an actual line there. So believe it or not, the blue, when it's folded over that orange line, the blue, see, it goes over the orange, becomes this, that one right there, and this one right here becomes this one right here. Okay, so reflect over there. This blue one becomes this red one, and this red one becomes this blue one. This blue one becomes here, and this blue one becomes this red one here. So this blue becomes this red, and this blue becomes this red. Okay, that's what's happening there. So, okay, you have the line y equals x is already there for you, so you have the table, so you plug in those points. You're going to get 0, -1. Oh, 0, 1, my bad. Let's try 5, -3. And 4, 0. See, this is going to be helpful when you go into My Open Math and you do some of those graph questions. All right, you'll be able to see that. So you see that the green becomes the blue, and you switch x and y, and you fold it over that blue line right there. See what we have here, okay? Find the inverse of y equals x graphically, all right? So we could see that the red one is the original, and the blue one is going to be the inverse function. That's what's happening here. Yep, so the blue one is the inverse of the red one folded over that line. That's what you need to do for that one. Okay. Now, find the inverse of the function y equals x minus 1. So we're going to do that one right now. So, what do we have? We have y equals x minus 1. And we're trying to find the inverse. So the steps are switch x and y, and solve for y. So you have y equals x plus 1. Don't get comfortable with just doing the opposite operation of what you see, because they get more complicated as we move forward. So please remember the steps. You switch x with y, and then you solve for y. And they're not going to be all this easy. I just wanted you to know that. Okay? So we have y equals x plus 1. Find the inverse of y equals 2x plus 8. Okay? So you have y equals 2x plus 8. That's the original function. We switch x and y. We solve for y. And we have to divide by 2. So you're going to get y is equal to x over 2 minus 4. So we read it this way. Y equals x over 2 minus 4, which is the same as y equals 1/2 x. I don't know if you can see that. So you're going to have y equals 1/2 x minus 4. That's probably the way you want to write it. Okay? There you go. Find the inverse of this guy. So this one's a little more complicated, like I told you. Not always going to be able to see them right off the bat. Okay, and that's okay. So y is equal to 3x minus 4 squared. So what you're doing there is switch x and y. You get x equals 3y minus 4 squared. Okay, now you got to get that y by itself. So you take the square root of both sides. So square root, you're going to get 3y minus 4 is equal to plus or minus the square root of x. Okay, and then you get add 4, add 4, add 4. And you're going to get plus or minus radical x plus 4 equals 3y. And then divide by 3 and divide by 3. So you're going to get y is equal to 4 plus or minus radical x over 3. It's okay if you write it like that, that's fine. Okay, so find the inverse. So you have y equals x squared plus 4. You're going to get x equals y squared plus 4. Okay, and you're going to get x minus 4 equals y squared. And you're going to get y is equal to plus or minus square root of y minus 4. Show you a graphical representation of that problem right here. You might notice that the red function y equals x squared plus 4, the one we just did, it fails that horizontal line test. Okay, so the horizontal line test tells you if the function is 1 to 1. So it is a function because it passes the vertical line test. But the horizontal line test, if it hits more than once, it's not going to have an inverse. So that's why when you see this graph right here, when you see this graph, you're only going to see every x value doesn't have exactly one y value. You have two different y values here. So this is not a function. So if it's not a function, it can't be an inverse. So therefore, this function does not have an inverse. Just wanted to show you guys that. All right. So we have time for one more. So we take this function, you try to find the inverse. We switch the x's and the y's. We solve for y. So we're going to x minus 1/2 is equal to 2/3 of y. Then you multiply times 3/2. So it's going to be x minus 1/2 times 3/2. And it'll be 3/2 x minus 3/4 equals y. And that's our inverse function right there. I have to stop the video. Look for quizzes inside Google Classroom.